Welcome back to Vex Isn't Scary. This is part 2, and we're going over conditionals. Where we left off last, we played around with the attribute wrangle node. We discussed some basic coding concepts like syntax, which is the same as grammar in written language, variables, which are temporary holders for values, data types, which are the format of data that a variable holds, and attributes, which are variables which persist on a geometry as either point, primitive, vertex, or detail. In this part, we are starting with conditionals. Conditionals are logical flows that our code follows. If this happens, do this, else do this. We can also do things like, while this is true, do this thing, or repeat this thing until this other thing is no longer true. To set up a conditional, we have the type of condition, which could be if else, for each, or while. The best way to start with coding is always to do what is called pseudocode. This is where we simply say what we want the code to do. For example, if a point is above the origin, make that point blue. If else, make that point red. Let's code that in Houdini. So in Houdini, let's go ahead and drop down a geometry node. We can call this vex part to conditionals. And in here, all we're going to do is drop a cube. So we have this box, and we'll change it to a polygon mesh with more axis divisions. So we'll make this 8 by 8. Oh, that's 88 by 8 by 8. All right, so it just has a few divisions to it. Now we can drop an attribute wrangle. So that is attribute wrangle, or alternatively, just AW. So what we said was, if a point is above the origin, so that's the 0 point, make that point blue, else make the point red. In our Vex expression editor, press Alt plus E to make this a larger box. And in here, we'll do some coding. Firstly, we would need to fetch the position of each point, because we need to check if it is above a certain position. So we want the y-axis point position. All we have to do over here is say float y, because that's going to be our y position. You can also call it something like y-pos if that makes it easier for you, equals. And what we're going to do here is say v at p dot y. And then we put a semicolon, because that acts like a full stop. Very simply, what we're doing is we're creating a float for the y position, and it'll be equal to the current point's p value, but the y component of the p attribute. So we're fetching the y position of all of our points, and then we can do things with them. So on the next line, we're going to start with a conditional. We want to say, if a certain condition is met, do this, else do this other thing. And it's exactly like that. You say if, and then you use these round braces. And inside of your round braces, you will put the condition that needs to be met. And then after that, you'll have curly braces. And so you have round braces followed by curly braces. And then if you put some spacing between that, it makes it a lot easier to see what's going on. So if this condition over here is met, run the code inside of the curly braces. So once again, if the round braces code is true, so if it returns true, then run this following code in the curly braces. What do we want to check? We want to check if the y position is greater than 0, right? We want to check if it's above the 0 point. So all we have to do is say if y-pos, right? That's the value we created. That's a variable. Greater than, so we use this greater than symbol, 0. So this is our condition. If it's true, then this code inside here will run. If it's false, nothing will happen. And so now let's actually give it something to do if this condition is true. Inside of your curly braces, press tab. What that will do is it'll indent. And this is just a formatting method so that it's easier to read your code. We say if, and then inside of that, the code to run, and then we indent it. So we know that this code falls inside this conditional. What we can do now is we can say v at cd dot x equals 0. So we want to make this blue. Remember, x, y, and z. So we put a semicolon there. V at cd dot y equals 0, semicolon. V at cd dot z equals 1. So if we apply and accept, we have a cube that is blue anytime it goes above this 0 position. And that's kind of cool. And so now if we increase our axis divisions on our box to maybe 15 by 15 by 15, and then put a transform node before this, and then a transform node after our wrangle, we can play around with this. So go to your transform that happens before your attribute wrangle. On this transform, we're actually going to move our box up. And what you'll notice is that because this attribute wrangle runs after our transform, it only does these calculations afterwards. So it adjusts. If our box is up here, all points are blue. If it's down here, all points are white. But if we adjust the transform after our attribute wrangle, you'll notice that this stays the same because this attribute wrangle has already run. It's already changed our color attribute. And now those conditions no longer apply. Anything that happens from here on out doesn't affect anything up the chain. So we can just delete these two transform nodes and continue. Press Alt-E to bring this back up. And now we have our conditional. Now we don't end our condition with a semicolon. We only end our lines of code with a semicolon like this. So far, so good. Now the next thing that we want to do is say if our points are not greater than 0 on the y-axis, make them red. And this is where an else statement comes in. Now, you could also use another if statement. You can say if y pars less than 0, do the following. But what happens is if you have an if statement, you can check for any other occurrence that doesn't fit this description. So you can put an else, and an else always has to be paired with an if. So we have else and then curly braces. And inside here, we can do other code to run. So if the one condition is true, run that code, else run this code. And in here, we can say v at cd dot x equals 1, v at cd dot y equals 0, v at cd dot z equals 0. And so that should make every point that is not meeting this condition red. And if we apply and accept, that's exactly what happens. All points above 0 are blue, all points below 0 are red. So let's press Alt-E to bring this back up, and there's a few things that I want to bring to your attention. Firstly, when we say greater than 0, we're saying anything above 0. But what about 0 itself? Well, we're not including 0. If we wanted to include 0, we can change this greater than sign. And this greater than sign is what is known as an operator. And there are other operators that you can use inside of a conditional. They are greater than, as we have, less than, then you have greater than or equal to, less than or equal to, is not equal to, or is equal to. And we can also combine conditionals with and, which is 2 ampersands, as well as or, which is 2 bars. So we can also make this greater than or equal to. And this is how you do it. You say greater than, equal, right? Apply accept. And now it includes the points that lie on 0 as well. Alt-E to bring this back up. And so what this is basically doing is it's checking this code, and it either returns a 1 or a 0. 1 being true, 0 being false. And that's known as a Boolean. And you may have heard of a Boolean before. Basically, it's just 0 or 1. Right? It's a true or false. So if you have to say something like if 1, and then you apply and accept, then this statement is true. If you make that if 0, it's false. So a conditional can also be a variable or a constant value like 0 or 1, and that's okay too. We're going to keep this as y pos greater than or equal to 0. Press Alt-E to bring this back up. Now what happens if we wanted an extra statement? So say that we wanted to check if a position is positive on the y-axis, then make it blue. But if it is positive on the y-axis and positive on the x-axis, make it green. You could do that. So firstly, we would need to fetch our x value to test. So we can say float xpos equals v at p dot x, semicolon. Now we're fetching our x position of all of our points as well. So now that we have our x position, we can go ahead and after this else statement, we can add another if statement if we want. Or we could even add it inside of this if statement. So you can have nested if statements. But I want to show you something different. So I'm going to go down here and say if ypos greater than or equal to 0 and xpos greater than or equal to 0, then in these curly braces, we're going to do the following. So now we have two conditionals. We have if our y position is greater than 0, and if our x position is greater than or equal to 0, do some things. Then we can say v at cd dot x equals 0, v at cd dot y equals 1, and v at cd dot z equals 0. Don't forget your semicolons, and then we can apply and accept. Now, as you can see, there is this section that's been made green. So we're saying, if the y position is greater than 0, make it blue. So we make everything above here blue. And then it says, for everything else, make it red. And then we say, if it is greater than 0 on the y-axis and greater than 0 on the x-axis, make it green. As you can see, we're developing a very logical flow going here. And this would be something that's difficult to do by hand or with other nodes. And this is where Vex starts to become very useful. So I'm going to bring up our code again with Alt-E, and we're just going to look at it for a second. Now, our code is starting to get a bit drawn out and a bit long because we're setting 3 different components for each of these conditions. And all we really want to do is change color. So surely it shouldn't be this difficult to change color. And it isn't. We can use what are known as functions to shorten our code. Functions are bits of code that do some extra work behind the scenes. You can think of them as a chef. You give your chef some ingredients, they follow a recipe, they give you an output. You don't need to concern yourself with the recipe, only with making sure that the ingredients are right. In our code, we can shorten our v at cd with a function. So in our if y pos greater than or equal to 0, we can remove all of this, press tab to indent. Then we can say v at cd equals set, and then open some round brackets. Now you'll notice that set is this teal or turquoise color, and that means it's a function. And functions are followed by round brackets. And inside of here, they take arguments. So what an argument is what I just said. It's the ingredient. It's what it needs to run over so that it can give you an output. And what we want here is to tell it to make our points blue. So we say set 0, 0, 1, and don't forget your semicolon at the end of the line. Now if we apply and accept, we have the same thing, but we have much shorter code. So back in here, you can Alt-E, and we can do the same for the others. So over here, we say v at cd equals set. This one we had as red, so that is 1, 0, 0, semicolon at the end. Down here, we could say v at cd equals set 0, 1, 0, semicolon at the end. Apply, accept, the exact same thing. So all this is doing those 3 lines of code that we had as 1 line of code. And this is a very basic one. You can have much more complex functions. And to find a list of functions, you can go over to the SideFX website. They have Vex documentation over there. So if you just open up a tab, you can go to sidefx.com. And if you go over to support, you can go to documentation, Houdini 18, and it has all of this documentation, but we're looking for Vex. So towards the bottom right, we have vex. And if you go down over here, you have vex functions. And what I would do is I would bookmark this page. Alternatively, if you don't feel like going to the vex functions page, you can say vex set. And the first thing that comes up will give you a description. As you can see over here, it says the set function has a wide variety of forms allowing you to perform many different types of conversions. This is the one that we used over here. Vector, right? We had a vector, that was our color, and we set it with 3 floats. It was our value for our color, so 001 in the case of blue. And you can see that there are a whole bunch of functions, and I wouldn't suggest learning all of them. I use maybe a handful. I use maybe 50 of them, max. Commonly, I'll use about 10 of them. And so we'll learn those 10 in depth, and then we'll touch on the extra 40 or so that I use quite often. And so don't worry about this too much. You can just visit the documentation. If you are trying to get something done, you can also Google something like vex setting vector, right? If you need some help, then a lot of the time the first thing that will come up will be related to what you were looking for. So when we're done with that, back in Houdini, apply, accept. So what has this allowed us to do? Well, if we put a transform node over here, we can actually just set our rotation on one of these axes to maybe $FF times 3. And if we play this back, kind of interesting, right? And if we had to increase our axis divisions to 80, 80, 80, you can see the sort of thing that you can accomplish with a little bit of vex code. And you can make this even more interesting, adding a transform afterwards. You can do something like a rotation on y, $FF times 4. Right, and things start to get a little bit funky. So $FF times 2. Right, pretty weird. And so you can do some cool things with vex, and this is just our very basic starting point. So in the next part, we're actually getting into functions. This was just to touch on functions, but mainly we were looking at conditionals. If this, then that, else something else. And remember, always try and do this in pseudocode. It makes it a lot less intimidating. Always think to yourself, what would I like this to do? And then speak yourself through it, and then try and actually code it. So in the next part, we'll be doing a lot more interesting things. This was all just to set you up, but now we have a basic understanding of vex, and we can continue from here. So thank you for watching. I hope to see you next time. Bye.